this series of short videos, we'll take a look at organic chemistry in capsule form. So that's why organic chemistry capsule. So the very first one is about loose dot structures. So you see loose dot structures part 1. Do a series maybe 3-4 on loose dot structures. Organic chemistry starts off maybe with loose dot structures, which you are familiar with already from a previous chemistry course. And here I have a periodic table because most of our discussion will focus on the second row elements and third row elements. Many organic compounds will, of course, organic compounds are compounds of carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur, chlorine are the halogens, and some metals here, transition metals, but we'll come to that. Start slow. So loose dot structures are important to learn how to give a structure, because there are millions of organic compounds and a given molecular formula does not give a complete structure. And molecular formula is just a molecular formula, not a structural formula. For example, two compounds may have the same molecular formula, but the structures will be different for both of them. So we need to look at the structural formulas. For that, let's just briefly review this. First row we have hydrogen, helium. Second row we have lithium, beryllium, boron, carbon. So you know the atomic number. Hydrogen atomic number is 1. Helium is 2, lithium 3, beryllium 4, 5, 6, 7, 8, 9, 10. And one thing we already know from the periodic table is these elements, helium, neon, argon, krypton, so on, they are called inert gases. They do not normally react. The reason for that is because their shell is full. The first shell, helium 1s2, that's full. There's no more space for electrons in that shell. Similarly, second shell we have the electronic configuration is 1s2, 2s1 for lithium. Goes like this and becomes 1s2 for neon. It becomes 1s2, 2s2, 2p6. The shell is complete. So neon is happy. It does not need to react with something else, another element, to form compound. Its valence is satisfied. But take a look at carbon. Carbon has 6 electrons. It needs 4 more electrons to become like neon. So it tends to react, make 4 bonds. For example, it can make 4 bonds with hydrogens, 4 hydrogen atoms, so to make a molecule. CH4, methane. So this formula is called the molecular formula. I tend to abbreviate stuff, so molecular formula. Given a molecular formula, how do we arrive at the structural formula? So that's where we come to loose dot structure. So let me erase this. So keep one thing in mind. So carbon needs 4 electrons to become like neon, so carbon forms 4 bonds. Nitrogen needs 3 electrons to become like neon, so nitrogen forms 3 bonds. Oxygen forms 2 bonds. Fluorine forms 1 bond. Okay. So let's look at this from how to draw loose dot structure. So molecular formula is CH4. So there is a simple equation here called the equation is used to determine how many bonds are in this molecule. And the equation goes like this. Number of bonds for this molecular formula, CH4, is given by demand. We'll come to what demand is, what supply is, by 2. So what is the demand? Demand is the number of electrons each atom requires around it. So carbon, we saw previously, carbon has 6 electrons total. 4 electrons are in the outer shell. So carbon has 4 valence electrons. Total 6 electrons, but valence electrons are 4. Those electrons that are in the second shell, outermost shell. Hydrogen has 1 electron, and it is the valence electron. So if you look at the supply, demand, you're looking at demand, carbon demands 8 electrons around it. Carbon demands 8 electrons around it. If it has 8 electrons, it feels like neon and a net gas. Hydrogen, each hydrogen needs 2 electrons, because if it gets 2 electrons, it feels like helium, so it's happy. So there are 4 hydrogens. Each hydrogen requires 2 electrons, so 4 hydrogens require totally 8 electrons. So total demand is 16 electrons. Total demand is 16 electrons. Now let's take a look at the supply side. So carbon, we already seen carbon has 4 valence electrons. Each hydrogen atom has 1 valence electron. So 4 hydrogens will have total 4 valence electrons. Total 4 valence electrons. So the supply is 8 electrons. So we have established the supply here as 8 electrons, and the demand is 16 electrons. So now let's plug these numbers in this equation. Number of bonds equals demand minus supply divided by 2. So that will give us demand minus supply by 2 is number of bonds. So 16 minus 8 by 2 is 4 bonds. So we have established that CH4 will have 4 bonds. Now let's draw the Lewis dot structure for that. So carbon, we have seen carbon has 4 valence electrons. We are representing the 4 valence electrons of carbons by dots. That's why we got the Lewis dot structures there. So now each of the hydrogen atoms is bringing in 1 electron. I'm using a different colored pen. So hydrogen, this X electron, this just to denote differently. Each hydrogen atom is bringing in 1 electron. So carbon is forming 1 bond with hydrogen. There. So we have, this is the Lewis dot structure of methane, which can be simplified to this structure, where this line represents a bond, and the electron, there are 2 electrons there, and they are called the bond pair, as opposed to lone pair, which we'll see later. So you see 4 bonds. You see 4 bonds here. Now again, let's take a look at whether the demand of each of these atoms is satisfied. We said carbon demands 8 electrons. That's where you get the octet rule. The octet rule. So the second row elements that we have seen before, second row elements tend to satisfy the octet rule. They need 8 electrons around that, especially carbon, boron, carbon, hydrogen, nitrogen, oxygen, fluorine. So you see, carbon has 8 electrons around it, and each of the hydrogen atoms demands 2 electrons around it. So each hydrogen atom has 2 electrons around it. So all the hydrogens are happy, and so is the carbon. So this way, they share the electrons and make 4 bonds, and you have methane. So methane, the CH4 is the molecular formula, whereas this one is a structural formula. This is a simple compound, so it looks easy. But as you move, if we take another example, C2H6. We'll take that up in a different video because this is capsule, so we'll keep them short. In the next video, we'll take a look at 3 structures or 4 structures. CH3OH, that will be the molecular formula will be CH4O. CH3NH2, the molecular formula will be CH5N. those three examples in the next video. So see you in the next video.